Oh my goodness, I am so excited to share these instant noodles with you all today because not only are they super spicy and have that mala Sichuan flavor that I love, it also requires science to make. This packet of noodles actually contains a heating element that is a package of chemicals that when you add water creates an exothermic reaction to actually cook the noodles. So not only will I be showing you how to make this, I will also be explaining the science behind that chemical reaction with all the electrons and everything. So stay tuned and take a look at how that works. So in the meantime, we're going to prepare the noodles. And the top chamber contains these very clear instructions in both English and Chinese, as well as some very clear warnings on how not to make this. And then there is a seasoning packet, a packet of vegetables, and some chili flakes. And on the bottom chamber contains some sesame oil and some chopsticks. At first I thought this was food, but turns out that they're just plastic chopsticks. Here is some yam vermicelli, as well as the heating pack that actually contains the chemicals that will cause the exothermic reaction. Lots of warnings here as well, which I appreciate. I mean, this is kind of a dangerous process, as you will see. So in the instructions, it says to first put the vermicelli noodles onto the bottom of the upper chamber. And they kind of are an interesting texture. They feel quite rubbery and they're a bit stuck together, so I thought I would just separate them all up so that they cook a little bit easier and don't end up as one gigantic all stuck together clump when things are done. Next, this is pretty familiar if you saw my other instant hot pot video, but it is a bag full of amazing vegetables. Oh my gosh. There's lotus root, potato, that bamboo shoot that just shot out, the really big chunks of them, as well as potato and cloud ear mushroom. And I am just going to use the chopsticks that they provided in the kit, which I found a little bit hard to assemble, but I'm just going to spread out the vegetables before putting these chili flakes on there. Now in the instructions it says, I think that you can use these chili flakes and the sesame oil to dip the food into, kind of like a condiment, but I just decided to throw everything in there. All right, just gonna toss in the rest of the stuff, including the seasoning packet, as well as the oil. And then next is to pour some water into the top chamber. The instructions say that it'll taste better and be more effective if you put in already boiling water on the top, but I wanted to mimic what would happen if I was actually out camping or if my power was out. So I just poured in some room temperature tap water onto the top chamber, making sure not to overflow it. And then it's time to open up the heating element. It's kind of this thin fabric packet full of powder. It wasn't like super rigid or anything like that. And then there is this kind of difficult to see water line. It's marked a little bit better on the outside, but you only want to fill the water up to that point on the bottom chamber. And again, I use my room temperature tap water to fill it up to that line. And you can see that the packet is pretty absorbing. So it starts to absorb some of that water that I had just poured in, but it takes a little bit of time. So I sped this footage up 4 times so you didn't have to wait and watch me just poke it and be super impatient. I had no idea how long it was going to take. I don't think that was in the instructions, but oh my gosh, just wait and see. About 1 minute and 10 seconds later, it all of a sudden inflated really big, so I put on the top chamber and then bam! All of a sudden, steam just started pouring out, so I quickly covered it and set my timer for 10 minutes because the instructions said wait 8 to 10 minutes. And in the meantime, I'll explain to you the chemical reaction that's occurring with the calcium oxide that's present inside the heating packet and the water that we just poured on. So calcium's atomic number is 20 and oxygen's atomic number is 8, which means that there are 8 electrons that surround the nucleus of the oxygen atom. And water contains 1 oxygen atom and 2 hydrogen atoms. So let's take a look at what happens when we combine these on an atomic level. So a calcium atom contains 20 protons, which I've put in the nucleus in black here, as well as 20 electrons in a cloud around it. And based on how these electrons like to organize, there are going to be 2 electrons in its outer shell, which we call valence electrons. Oxygen only has 8 electrons, but also has a preferred configuration which causes 6 electrons to be in its outer shell, which is lower than its preferred amount of 8, so it bonds with calcium and borrows 2 of its electrons to create a bond so that both calcium and oxygen are satisfied. Now, oxygen we just drew, I'll just draw it again over here to be represented in the water molecule, again with 6 valence electrons. And then hydrogen has an atomic number 1, meaning it has 1 electron, but we've got 2 of those in water. And again, these can bond with the oxygen atom to create the preferred number of 8 valence electrons. Now we've got our calcium oxide molecule and our H2O molecule, and these, when they come into contact, want to be in an even more stable condition where the hydrogen from the water bonds with the oxygen in the calcium oxide, and then we end up with this molecule that is perfectly symmetrical and much more stable than the reagents separately. So this is a reaction that happens very quickly because it allows the molecules to be in their preferred state. And this is called calcium hydroxide, CaOH2. Now, how does this create heat? It actually created heat when the bonds were formed in the combination of the H2O and the CaO. And that is how we were able to heat up our hot pot. You can see a little bit of steam still going here after about 10 minutes, and it smelled so good, and I was so ready to dig in. And the reveal. Look at that steamy goodness. It smelled so good, and I was surprised by how hot everything was. Just gonna give everything a quick little mix and check on these noodles. They are definitely a lot bigger than they were, much more hydrated, and they were delicious. They were basically perfectly cooked, a little bit chewy but soft. So I think this is a really great meal to have if you don't have access to fire, but it was really expensive. It was about $15 as opposed to basically all the same ingredients minus the noodles was about $5 when I bought the instant hot pot mix that you cook on the stove. So all in all, I don't think I would buy it again, but I definitely did enjoy making it and learning about the science behind it, as well as sharing it with you all. And it was even slightly better than the other mix I had because I didn't find any major flaws with it. The bamboo shoots were all pretty tender this time. I did not have any pieces that were too chewy, and I did not find any grains of sand, which I found in the other one, so that's good. And here is the calcium hydroxide that we made with the chemical reaction. It is rock hard now and much bigger than before, so I found that was pretty interesting. And I love this Sichuan flavor so much. It was super spicy, so don't buy this if you don't like spice. But I wanted to make one more use out of it before I toss it away. So I am actually mixing peanut butter with the leftover soup. I know it sounds crazy, but check out my next video for how that turns out. And bonus, this product is actually vegan, and I believe also gluten-free because the vermicelli is made out of sweet potato. So all in all, I give this product an A+ if you're made of money, but check it out, have fun, and like and subscribe, and I'll see you next time. Thank you.